This is AJH welcoming you on behalf of Edexemy to the next part of the Matrices series. Come, let's see.
Now we are into the green screen. Here is one problem. We are going to solve this problem. A matrix A is given and we have to prove that A inverse is equal to A transpose. This is the matrix A and we have to prove A inverse is equal to A transpose. Let's solve this. First we will find A inverse, then we will find A transpose. Here you have to note that one constant is multiplied with a matrix and both of these combinedly form matrix A. Okay. Now, how to solve this type of problem? We will take A is equals to 1 by 9 of a matrix. Now we will find A transpose. Now keep that 1 by 9 as it is. We change the column into rows. Minus 8, 4, 1. First column into first row. Second column 1, 4, minus 8. Third column 4, 7, 4. Now this is the value of A transpose. Take this as result number 1. This is result number 1. Okay. Now we will find inverse of A. What is inverse of A? You know how to find inverse of A. Now, a constant multiplied by a matrix and the inverse is equal to, take that constant outside, then it will become 1 by constant, 1 by lambda A inverse. This is the formula. This is the formula. Now, if we take any constant out of a inverse, it will become 1 by constant. We know that. You have to write this formula. So, therefore, A inverse is equal to, if we take that 1 by 9 constant outside, it will become 1 by 1 by 9. So, inverse of A is equals to 1 by 9 into a matrix of minus 8, 1, 4, 4, 4, 7, 1, minus 8, 4, the whole to the power of minus 1, inverse. Now, if we take the constant 1 by 9 outside, it will be 1 by 1 by 9. Okay. 1 by 1 by 9. One by 9 into the inverse of the matrix minus 8, 1, 4, 4, 4, 7, 1, minus 8, 4. Write that matrix. Inverse of this matrix. 1 by 1 by 9 is 9. If we take 1 by 9 to the numerator, this will become 9 by 1, therefore which is equals to 9. Therefore here 9 into, we have to find the inverse of minus 8, 1, 4, 4, 4, 7, 1, minus 8, 4. Okay. We will take this matrix as B. We will take this matrix as B. Then A inverse is equals to 9 into B inverse, where B is equals to this matrix. You have to write here, this matrix you have to write here. Okay. Now the first thing we have to do is find the inverse of B. What is the inverse of B? Okay. Now we will find B inverse. We know how to find inverse of any matrix. 1 by determinant of B into adjoint of B. So we have to know two things. First, determinant value of B, then adjoint of B. So expanding through row 1, you will get a minus 8 into 4 into 4 is 16 minus, here one minus is there, therefore plus 7 into 8 is 56 plus minus 1 into, leave that row and column, 4 into 4 is 16 minus 7 plus 4 into, leave that row and column, you will get minus 4 into 8 is minus 32 minus 4. Now you simplify this, 56 plus 16 is equal to minus 8 into 72. 16 minus 7 is 9, minus 9. Minus 32 minus 4, minus 36. Therefore, plus 4 into 72 into 8. 72 into 8. 72 into 8. We can calculate like this. 8 into 70 is easy to calculate, 560, then 2 into 8. You split that 72 into 2 parts, 70 plus 2. First multiply by 70, it is easy, 560, and 8 into 2 is 16, 576. You can do this mentally. Therefore 576 minus 9. Here one minus is there, minus 9. Here also this is minus 36. Minus 32 minus 4 is equals to, now 144. Here minus 32 minus 4 will be minus 36. Therefore, here it will not be plus, this will be minus. So you have to be very careful putting these signs. Now the total value is minus 729. Minus 729. Therefore, now we will find adjoint of B. Now what is adjoint of B? Adjoint of B is equals to this matrix B. You have to write the cofactor and find the transpose. First the cofactor matrix. What is the cofactor matrix here? First, for minus 8, we will find the cofactor matrix. We have to put the plus sign here and leave that row and column, and for the first element it will be determinant of you leave that row and column, you will get 4 7 minus 8 4. 4 7 minus 8, 4. And the second element, you put minus here, then determinant value of, leave that row and column, you will get 4, 7, 1, 4. 4, 7, 1, 4. Okay. For the third element, you leave that row and column, you will get 4, 4, 1, 8, 1 minus 8. Now put minus here, then you leave that row and column, you will get 1, 4, minus 8, 4. You must be very careful with the plus or minus sign. Here plus. Now leave that row and column, you will get minus 8, 4, 1, 4. Minus, leave that row and column, you will get minus 8, 1, 1 minus 8. Leave that row and column, you will get minus 8, 1, 1 minus 8. Okay, the last row for 1, it will be plus determinant of, leave that row and column, you will get 1, 4, 4, 7. 1, 4, 4, 7. Now minus of, what will be the determinant value? Leave that row and column, minus 8, 4, minus 8, 4, 1, 4. Leave that row and column, minus 8, 4, 4, 7, and then next last one is plus determinant of, leave that row and column, you will get minus 8, 1, 4, 4. The whole matrix, transpose of this whole matrix will give you adjoint of B. Now we will simplify this and find what is adjoint of B. Okay. Now this is equals to, this is equals to 4 into 4 is 16, minus of minus plus, plus 56. Okay, similarly we will solve the other determinants. 4 into 4 is 16, minus 7, minus 7. Okay, then minus 8 into 4 is minus 32, 4 into 1 is 4. For this, minus 4 minus minus 32, minus of minus is plus 32. For this, minus 32 minus 4. Okay. Minus 8 into minus, here put minus here, minus into minus plus, 8 into 8 is 64, minus 1 into 1 is 1. Okay, 1 into 1 is 1. Okay, the last row, 7 into 1 is 7 minus 16. 4 into 4 is 16. Here minus you put here, 7 into 8 is 56, minus 56. Minus of 4 into 4 is 16. 16. Okay, the last one, minus 32, minus 4. Minus 32, minus 4. For this whole cofactor matrix, you find transpose. Now we will simplify each and every element here and find the adjoint of B. Now it is 72. 56 plus 16 is equal to 72. And 16 minus 7 is 9 minus of 9. And this is minus 36. And the next one is minus of 36. And the next one is minus 36. And the next one is 64 minus 1 is 63, therefore minus 63. Minus 63. Okay. 7 minus 16 is minus 9. 56 minus 16 is minus 72. Minus of minus is plus, therefore 72. Minus 36. Minus 32 minus 4 is minus 36. The transpose of this cofactor matrix. Now change the rows into columns. Now there is a 9, each one and every one of this element will take that 9 outside first. If we take 9 outside, the first element will become 8. 8 into 9 is 72. And the second one, take minus 1, minus 4, minus 4, minus 4. Take 9 outside from each and every element. So if we take 9 outside, then divide 9. Each of the element you divide by 9. And the transpose of this. What is the transpose of this matrix? 9 into 8 minus 4, 1, minus 1. Minus 1, minus 4, 8. Minus 4, minus 7, minus 4. Now this is the value of adjoint of B. Now we will substitute this value in the result. A inverse, we have already find out, no, A inverse is equal to now A inverse B inverse, first we will find B inverse is equal to 1 by determinant of B into adjoint of B. Okay. Now B inverse is equals to, what is 1 by determinant of B? 1 by determinant of B is 729 minus 729 into this adjoint value into 9 into this matrix of 8 minus 4 minus 1 minus 1 minus 4 8 minus 4 minus 7 minus 4. Okay. Now how many 9s are there in 729? We will find out. Therefore minus of 1 by 81, I think. 8 9s are 72, 1 9s are 9, 81. Therefore 8 minus 4 minus 1 minus 1 minus 4 8 minus 4 minus 7 minus 4. Now substitute this value in the previous result. A inverse is equals to 9 times of B inverse. We will substitute the value of this B1 here. Then what we will get? This is result number 2. Put the result number 2 in 1. We will get A inverse. Okay. Okay, we will move the canvas little bit outside. Now you substitute the value of P1 here. Now this is equal to 9 into what is B, minus of 1 by 81 into 8 minus 4 minus 1 minus 1 minus 4 8 minus 4 minus 7 minus 4. Okay. Now this is equals to minus of 1 by 9. There are 9 nines in 81. Therefore 8 minus 4 minus 1 minus 1 minus 4 8 minus 4 minus 7 minus 4. Okay. Now take this minus value to inside, then all the 1 by 9, and the sign of all these elements will change. Plus into minus, minus into plus. Plus 8 will become minus 8, minus 4 will become 4, minus 1 will become 1, 1, 4, minus 8, 4, 7, 4. Okay. Now what is this? This value is equal to A transpose. I have already found out, no? A transpose equal to 1 by 9 into minus 8 4 1 1 4 minus 8 4 7 4. The same thing we get for A inverse. Therefore A inverse and A transpose are equal. A inverse and A transpose are equal. Therefore proved. A inverse is equal to A transpose. The problem is over. We will move on to the next problem. Two matrices are given, A and B. These two are 2 by 2 matrices, and we have to verify that AB to the whole inverse. Inverse of AB is equal to B inverse multiplied by A inverse. AB inverse, inverse of AB is equals to, this is actually a formula, a theorem. So we have to prove this with the help of two matrices. Now we will solve this, we will verify this. Okay, first we will find the product of AB and the inverse of AB, then we will find inverse of B, inverse of A separately. Now what is the product of AB? You know how to multiply two matrices. Matrix A is 3 2 7 5 and matrix B is minus 1 minus 3 5 2. How we will multiply? Take the first row, multiply with the first column. Therefore here 3 into minus 1 is minus 3 plus 5 into 2 is 10. Therefore minus 3 plus 10. Take the first row and multiply this first column. Now take the first row and multiply the second column. Minus 3 into 3 is, I will put a bracket here, minus 3 into 3 is minus 9, plus 2 into 2 is 4. Okay. Now take the second row and multiply with the first column. 7 into minus 1 is minus 7. 5 into 5 is 25 plus 25. Now the last element will be, take the second row and multiply with the second column. 7 into 3 is minus 21. 5 into 2 is 10 plus 10. Okay. This is the product of AB. We will simplify this. Okay. 10 minus 3 is 7. 10 minus 3 is 7. Minus 9 plus 4 is minus 5. Minus 7 plus 25. 25 minus 7 is 18. and minus 25 plus 10 is minus 11. This is the value of AB. Okay, now we will move on to find the next thing. We will find the determinant value of AB. To find the inverse of AB, we have to first find the determinant value of AB. What is the determinant value of AB? 7 into minus 11 is minus 77, minus of 18 into 5. There is already one minus here, therefore minus into minus is plus. 18 5s are 90. Just half of 18 is 9, put a 0. That's the simple way to find multiplication of any number with 5. Therefore, 90 minus 77 is 13. This is not equal to 0. Therefore, inverse of AB exists. You have to write, you must write all these things in your exam paper. Now, we will move on to find AB inverse. Before that, we will find determinant value of A. It is 15 minus 14 is equal to 1. Determinant value of B, we will find determinant value of B. What is 2 into minus 1 is minus 2. Minus 2, minus of minus will become plus 15. Minus of minus will become 15, therefore 13. So, we have now found out a determinant of AB, determinant of A, determinant of B. Now we will find AB inverse. Inverse of the product AB, 1 by determinant of AB into adjoint of AB. Adjoint of AB. Okay, it is easy to find adjoint of AB for a 2 by 2 matrices. Now, 1 by 13. The determinant value is 13. Now, this diagonal you change the elements. Minus 11 will come here, 7 will come here. These elements will remain the same, but this sign, you change this sign value. Minus 18 will become minus 18, minus 5 will become 5. So, this is very easy to find adjoint of AB. Therefore, you take this result as 1. Now, we will find B inverse. Now, what is B inverse? Now, B inverse, A inverse equal to, we will put all the results here, 1 by 13. 1 by 13 into 2, 3. Minus 5, 1. 5 minus 2, minus 7, 3. So, simplify this. You know how to find A inverse and B inverse. 1 by modulus of A into adjoint of A. Similarly, you can find B inverse also. Simplify this, you will get 10 minus 21 is minus 11, and okay, take this result as 2. Here what my 1 by 13 is here, don't forget to put 1 by 13. Here is 1 by 13, no. I have to put here. Now compare this 1 and 2, both results are same. Therefore, AB inverse is equal to B inverse A inverse. The product AB inverse is equal to B inverse A inverse. Proved. Now we will pass on to find the third problem. Now adjoint of A is given and we are asked to find inverse of A. The formula is A inverse is equal to plus or minus 1 by root of determinant value of adjoint of A into adjoint of A. You have to memorize this formula. We are going to use this formula. If adjoint of A is given and we are asked to find A inverse, this is the method. First we will find a determinant value of adjoint of A. Now expanding through R1. You have to write this expanding through R1. Expanding through R1. Now 0 into anything is 0, minus 2 will become, now minus, already one minus is here, minus 2 into minus is plus 2, minus of minus plus 2 into, leave the row and column, you will get 6 into 6 is 36, minus of 6 into 3 is 18, minus into minus plus, therefore 36 minus 18, and 0 into anything is 0. 36 minus 18 is 18, 18 into 2 is 36, therefore the adjoint of A determinant is equal to 36, which is not equal to 0, therefore A inverse exists. Okay, adjoint of A inverse exists. Now we'll find A inverse, substitute this determinant value in the formula 1 by root of 36. You have to put one plus or minus before that, and adjoint of A. Adjoint of A is already given. The matrix adjoint of A is given, therefore you can straight away put that matrix 0 minus 2 0 6 2 minus 6 minus 3 0 6. Now this is equal to, you have to put plus or minus here, plus or minus 1 by root of 36 is 6, therefore 0 2 0 6 2 minus 6 minus 3 0 6. This is the value of inverse of A. Now we'll pass on to find the third problem, solution for the third problem. Here A multiplied by a matrix is equal to another matrix. We have to prove this. Using this we have to find the matrix of A. Matrix of A. We will take B is equal to 5 3 minus 1 minus 2 and C is equals to 14 7 7 7. Then the given thing will become now A into B. What is this? This is B. AB is equal to C. This is C. Therefore AB is equal to C is given. Now we have to find matrix A. Now AB, now you multiply B inverse with this thing, post multiply. If you multiply in the left hand side, you have to multiply the same thing in the right hand side, therefore C into B inverse. If you multiply B inverse here, then you have to multiply B inverse on the right side also. Now B into B inverse gets cancel each other. This is a theorem. A matrix and its inverse will cancel each other, therefore A is equal to C multiplied by inverse of B. If you multiply C with inverse of B, you will get A. Now it is easy to find A. Now to this we have to find the inverse of B. For that, determinant value of B is equal to 5 into minus 2 is minus 10, minus of minus 3 is plus 3, therefore this will be equal to minus 7, therefore B inverse exists because it is not equal to 0, therefore B inverse exists. Now we will find what is B inverse. Now B inverse, what is B inverse? Now B inverse is equals to 1 by determinant value of B. What is this? Into adjoint of B. Now what is this? Determinant value of B minus 7. Therefore minus 1 by 7 multiplied by adjoint of B. What is adjoint of B? Change this elements in the diagonal. Minus 2, 5. And 1 minus 1 will become 1, 3 will become minus 3. That's all. Adjoint of B. Therefore, this is the value of B inverse. Now A is equal to C. C 14777 multiplied with this B inverse. What is B inverse? Minus 1 by 7. Minus 1 by 7. You put it here. Now this will become minus 2, minus 3, 1, 5. Okay. Minus 2, minus 3, 1, 5. Now we will simplify this. 1 by 7. We can take 7 outside of this. Then 14 will become 2, 7 will become 1, 7 will become 1. We can take that 7 outside. 1, 5. 7 and 7 will get cancelled. You will get minus of 2 into minus 2 is minus 4. 1 into 1 is plus 1. And take this row and multiply with the second column. 2 into minus 3 is minus 6. 1 into 5 is plus 5. Okay, similarly we will find the other elements. Take the second row and multiply with the first column. Minus 2 into plus minus 2 plus 1 and minus 3 plus 5. Now we will simplify this. Minus half. Minus 4 plus 1 is minus 3 and minus 6 plus 5 is minus 1. Minus 2 plus 1 is minus 1. Minus 1. Minus 5. 5 minus 3 is 2. Now take this minus inside. Minus 3 will become 3. 1. 1 minus 2. All the signs will change. This is the answer. Now we will pass on to find the solution for the third problem. Here 3 matrices are given and we have to find a matrix X such that AXB is equal to C. The condition is given as AXB is, if AXB is equal to C, then find what is the value of X. What is the matrix X? Now we are given A, B, C matrices. Now pre-multiply this AXB is equal to C. Given inequality AXB, you pre-multiply with A inverse. Now X into B. Similarly, you have to multiply with A inverse right hand side also. Therefore, A inverse into C. You have to pre-multiply both sides, left hand side and right hand. Now A into A inverse into A gets cancelled by theorem. Now we will post multiply this with B inverse. Now this will get cancelled. We will get X into B inverse, post multiply. Similarly, in the right hand side also, A inverse C into B inverse. Now B inverse will get cancelled. Finally, we will get what is the value of X. The matrix X equal to A inverse of C multiplied by B inverse. If you find this, we will get the matrix X. Okay, we will find A inverse and B inverse, then we will substitute in this. Okay, first A inverse. For to find A inverse, we have to find a determinant value of A. What is determinant value of A? 1 into 0 is 0, minus of minus is plus 2. Okay, 2. This is not equal to 0, therefore A inverse exists. Okay, similarly we will find what is B inverse. Now we will find A inverse 1 by determinant of A into adjoint of this one. So you change this elements, 0 will come upside, 1 will come here, 2 minus 1, the sign if we change it will become minus 2, 1. Now B inverse we have to find determinant value of B. This is 1 into 3 is 3, minus of minus is plus 2, 5. This is not equal to 0, therefore B inverse exists. Now we will substitute here. B inverse is equal to 1 by determinant value of B is 5, 1 by 5. Now adjoint. Change the diagonal elements, 1 come here, 3 will come here, 1 minus 2 will become minus 1, 2. So, we now know all the values of this A inverse C into B inverse. We will substitute here all the values. Therefore, the matrix S is equals to inverse of A half into 0, 1 minus 2, 1 multiplied by C. C is 1, 1, 2, 2, 1, 1, 2, 2 and multiply this with B inverse. This B inverse, okay. Now we will find, we will simplify this is equals to half. Now 0 into 1 is 0, 1 into 2 is 2, therefore 2. 0 into 1 is 0, 1 into 2 is 2, therefore 2. Minus 2 into 1 is minus 2 plus 2, 1 into 2 is 2 plus 2. Similarly, here also minus 2 plus 2. Therefore, into inverse of B. Now, we will take 2 outside from this matrix. Here it will become 0 and 0, minus 2 plus 2. Therefore, take 2 outside, already 1 by 2 here. Therefore, 2 and 2 will get cancelled. Therefore, 2 will become 1, or 2 will become 1. Here, 0, 0. This multiplied by B inverse, we will substitute here. What is B inverse? Okay. Therefore, x equal to 1, 1, 0, 0 multiplied by B inverse. What is B inverse? 1 by 5, 1, 2, minus 1, 3. Okay. Now take this 1 by 5 outside. So multiply both the matrices. 1 into 1 is 1, minus of 1. 1 into 2 is 2, minus of 3, plus 3. Here it will become 0 multiplied by anything, you will get 0. Okay. Now this is 0, 5, 0, 0. Take 5 outside, 5 and 5 will get cancelled, you will get 0, 1, 0, 0. This is the answer. Okay, this will be the answer.